Alright, here we go. Let's go through some of these. Let's get this all set up first. Here we go. Oh, we're not going to do them all. We'll do a sampling.
No one did any of them.
We'll do a sampling of them. Nah, we're doing something new tonight. So.
But we don't understand.
Well, you will after we do this. Oh, you want answers?
Well, yeah.
Goodness.
We don't have the answers.
You want answers?
Are you guys going to find
You're a needy group, aren't you? You're a very needy group. You want answers? It's crazy. Alright, let's write this thing down first, and I'll read off the answers to you. That's z. This is y. This is the square root of 3. This is 2 square root of 3 is the whole thing, right?
Yes.
From here to here. Oh, you laughing at my lines?
No.
What are you laughing at?
I wanted to keep doing Pythagorean
The
theorem
whole
for some
time
reason.
Sarah was like, let's just do Pythagorean theorem. And I was like, no, Sarah, you have to do it the right way.
She finally explained like how you do it.
You could. I mean, if you can use Pythagorean theorem, I have no problem with using Pythagorean theorem.
But then I don't
Even though we haven't technically learned Pythagorean theorem, but if there's a situation where you can use it, I have no problem with you using it. But we'll look at other ways. It didn't work anyway. Okay. Well, let's pause this while we read off the answers, and then we'll pursue this problem soon. Okay, we've read off all the answers. Now let's look at this problem right here. Trying to think of how to do this without Pythagorean theorem, but we could find this part right here. We'll call it W. Alright, just for they don't put a number here. But we could find this because, let me see if we need to, yeah, look, we could find this one, and then if I know what this length is from here to here, how can I solve for x? Subtract it from 2 squared to 3. Everybody see that? So if I can find this W, they didn't put the W in there, I just stuck it in there. But if we can find this, we could subtract it from 2 squared to 3 and we can get x. Do you agree? And then once we get x and once we get W, I could solve for y. And then once I get x, I could find z. So the key to this is finding this little bit right here that they don't even label. Anybody think about trying to find that? Nope.
That's what I said. But then I tried.
I was doing it wrong.
Okay.
That's what I tried to find. But then
So let's solve for that right there. How can we solve for that? Well, look, this is the geometric mean. Remember, these are my two sides of my right triangle. Do you see that? These are the two legs of the right triangle, and they are geometric means as well as this thing right here. This is geometric mean as well. So the square root of 3 is actually a geometric mean. So it's not a variable, it's actually a number that we know. So that's the geometric mean, so it's going to go here. But it's the geometric mean between what and what? Between the whole hypotenuse and the segment of the hypotenuse that's adjacent to that leg. Remember that? Okay, well it's between what? This is geometric mean between the whole thing and the segment that's next to it.
Yeah.
Alright? That's a quicker way to say it, don't you think? Alright, so between the whole thing, which is what? 2 square root of 3, and the segment that's adjacent to this, which is W. Right? Okay, and now I can solve for W, right? Watch this. You could cross multiply, but what would be easier? W is already up top. So just multiply by square root of 3 here. Why did I put over 3? Multiply by square root of 3 here. Multiply by square root of 3 here. Do you agree?
But there's a square root of 2 parts.
That's all right. Watch this. What's the square root of 3? Oh, let's do this. Bang, bang. You see that? They cancel out, don't they? Anything top and bottom, right? If they're being multiplied, cancel out. So what's my W? It's just the square root of 3 over 2. Agreed? Yes? No? You don't see the algebra there?
I see it. I don't see how the square root of 3, like, at the one part it cancels,
Right here.
but at the top up there it doesn't cancel.
It does cancel. I cancels here and here. I just did. I canceled them out. I got a square root of 3.
One side you can use the other side.
That's what I did. I multiplied this by square root of 3, and I multiplied this by square root of 3. This way I get 2 square root of 3's, don't I? So I got a square root of 3 here and a square root of 3 here. Well, one of these cancels out with one of these on the bottom. I don't care which one, but one of them.
Okay.
I could have canceled this one with this one if I wanted to, but I'd still be left with the same thing, wouldn't I? Does that make sense or not?
I get it now.
Okay. Alrighty. So W is the square root of 3 over 2. Square root of 3 over 2. But that's not really what I'm asking for, is it? But it's going to help me find x. How do I find x?
Isn't it?
I mean, think of these as regular numbers. Watch this. Watch this. Clear your mind of all the square roots. What if this was 2 and the whole thing was 5?
X is 3.
That would be 3, right? What'd you do? Subtract it. Same exact thing, right? It's just your numbers are a little uglier, that's all. So I take the 2 square root of 3. Let's do this let's go in the white. So I take 2 square root of 3, and what do? I subtract square root of 3 over 2. It's not near as hard as it looks. It's a simple little common denominator. What's your common denominator? It's 2, right? This is back in 5th grade you did this stuff. Not with square roots, obviously, but you did fractions, right, with different denominators, didn't you? Right? So 1 times 2, 2 times 2, which is 4. So this is going to be 4 square root of 3 minus, that didn't change, square root of 3. What's 4 square root of 3 minus 1 square root of 3? It's 3 square root of 3 over what? 2. That's x. Wasn't so hard, was it? So you're just getting bogged down in the fractions, right? I've said this ever since I've been here. We gotta do a better job teaching fractions, right? I kind of expect you to know how to do that before you get in here, but somewhere in the past we need to learn our fractions, okay? Because that really can help out here. All right, so I've got x. Is that the answer I read off? Good. All right, let's do another one. Let's go yellow. We can solve for y now because look, y is the geometric mean between what? Between the two segments of the hypotenuse. I know both of them now, don't I? So now I can solve for y. So let's set up a geometric mean again. So y is the geometric mean this time between what and what? Between this little part, which is the square root of 3 over 2, and this part right here. And what was that? That was 3 square root of 3 over 2. Right? Do we see this or not? Are we just stunned, or you're okay, go on, or what? All right. So remember, this is the geometric mean between the two segments. What if this was a 2 and a 3? What would you do? You'd go y, right, over 2 equals 3 over y, wouldn't you? It's the same exact thing, except the numbers just look a little more complicated, and you're freaking out a little bit because the numbers look a little uglier than just regular or whole numbers. All right, but this still works out the same. So let's do this. Let's cross multiply now. Actually, if you wanted to, let's just cross multiply. So y squared equals, now what do we do with these two? We multiply them together, don't we? So we write 3 square root of 3 over 2 times square root of 3 over 2. With me? All right. Well, it doesn't matter that they have a common denominator if you're multiplying them together, right? So we don't care about common denominators if you're multiplying. You only care about common denominators if you're adding or subtracting, right? I'm not going to square root just yet, right? I want to simplify this thing. Let's do the bottom first. What do we do? This is a multiplication problem. Nothing cancels. Just multiply straight across. That's right. Nothing cancels out, though. You can't cancel anything out.
3 square root of 9 over 4.
We'll show. Let's do the bottom first. What is that?
4.
4. Okay? Now watch. Here's the question. How do we multiply these together? Well, what is the square root of 3 times the square root of 3?
Be 9.
We talked about this on Friday, I think. It's the square root of 9, which is just 3. Remember, didn't we go through a process here? Because watch. What would be the square root of 7 times the square root of 7 be? 7. What's the square root of 19 times the square root of 19 equal to? 19. I don't even have to multiply 19 times 19, do I? Because what are you doing? You're taking a number and you're taking a square root and multiplying it by itself, correct? So for instance, if I had the square root of 3 and I multiplied it by itself, isn't that the same thing as saying the square root of 3 squared? Isn't that the same exact thing? And what happens with the squared and the square root? They cancel out and you're just left with a 3. So it's actually kind of easy, isn't it, to multiply these together once you realize how to multiply them, okay? Well, then you just, if it was the square root of 3 times the square root of 5, what would it be? Just be the square root of 15. Well, we'll take care of that in a second. We got to. That was the question though, right there, wasn't it? These two. So what's the square root of 3 times the square root of 3? 3 times this 3 is
9.
right.
And you have
And you got to. Well, you got to solve for y first, though, don't you? So how do you get rid of this square? You take the square root of both sides. And so, what's the square root of 9? And what's the square root of 4? That's y. There's your 3 halves. Isn't this fun?
This is not fun.
It is fun. It is fun. I'm loving it.
once you like kind of understand it, it's not fun, but you're not as frustrated.
Well, you know, it's not as fun as riding a roller coaster or anything, but it's as far as math is concerned, it's kind of fun.
Oh, God.
All right.
I'm not seeing it.
You're not?
I'm about to clean my room and do that. No, I hate cleaning my room. You don't understand what my room looks like. Yeah.
All right, let's do z. Come on. We're almost there. Let's do z. Z is the geometric mean between what and what? Between the whole thing, just like this was, and the side that's what? Adjacent to it. You see it? So z is my geometric mean, and then what numbers I'm going to put in here? This and this, right? Have we done that one already or not? No, we did. Now we did square root 3 over 2. So remind me. I got to scroll down. So remind me what those numbers are. So z is the geometric mean between the big one was what? 2 square root of 3, and the part the next to it was what? What was it? I told somebody to remind me. 3 square root of 3 over 2. Okay, let's just take a peek. Yep, 3 square root of 3 over 2. Not that I didn't trust you, Alex. I just wanted to look. All right, so now what do we do? Oh, that was the geometry. Our geometry is finished, right? The geometry part wasn't hard. It's just doing the algebra, right? So z squared, multiply these together, so it's 2 square root of 3. I'm going to put that over 1. Is that all right? Because I'm multiplying it by a fraction. 3 square root of 3 over 2. All right. Ow, now look at this. Now, somebody said on the other problem, cancel stuff out. Well, the other problem didn't have anything to cancel out, but you do here. Look,
2 and
this
2.
2, right, goes into this 2. So that was nice.
So what if just
Yeah, absolutely. It's multiplication.
Wouldn't it just be
Right.
9?
So it would be. Well,
Z would be
No, it
9.
would be 3. And then 3 times
it would be 3 after you take the square root. But watch this. Remember what we did earlier? Square root of 3 times square root of 3 is 3. Times this 3 is 9. So z squared is 9, but you got to take the square root of both sides, so z is 3. And there's your answer.
That took us 12 minutes and 30 seconds.
Well, it took me all that time to explain it, you know. So, I mean, just if I was just to do this straight up, it wouldn't take me near as much time. Okay?
I got it down.
All right. There it is. You can always review it again on YouTube.
Yeah, 'cause
Pick one more, because I don't have enough time to take this much time on all these.
No, 33 takes long.
Do 33.
32. Yeah, I got 32 wrong.
32?
Yes, please.
All right. What if you didn't?
Yeah, we didn't show our
Then
work
I'll
on any of them.
slap your wrist. All right. Okay, we got a triangle. It looks like this. Like that. And then this comes like this. Kind of looks like the same type of triangle. You don't like this chapter? It's only one section.
Well, it's already got my
It's already taken us like 3 days.
This is one of my favorite chapters.
Why are all of your favorite chapters the hardest one?
It's not.
I don't know.
Oh, stop. I said the quadrilateral chapter, the parallelogram chapter was one of my favorite, and you liked that one, didn't you?
Don't you? Do you
So that was a nice
I
one.
like the last chapter.
No, I don't at all.
You know why?
What do you think the X is? Is the X this one right here?
I like.
Because it's kind of far away.
I couldn't tell.
I think it's that one, because the 14.2 looks like it's the whole thing, doesn't it?
I think so.
Or does it? Man, it's hard to tell.
See, this is what I'm saying.
I think the 14.2 is the whole thing.
Why would they take the whole thing though if they didn't do the whole dash I don't understand why don't get a random person to just test out this math book before they use it. Like, take it.
I'm sure they do. I'm sure they do it many, many times.
And then student wasn't confused with that?
I think it's the whole thing. Because on the other one, like, for the 4.8 or for 33.
I feel like it's
All the other problems.
And it looks like the X is this one, doesn't it?
I don't know.
Yeah, I think this is right. Okay, well, all right, so what do we do? What do we do? What do we do?
I don't know. What do we do?
That's why we're asking geometric.
Would it be X?
Well, this is geometric mean between the two segments, and we don't know what the two segments are doing. Either one of them. We just know the whole thing. So we could do this. Ah, watch this. Remember how I put that W in there before? Look. Everybody watching? Look at this. So if I can't do it straight up like this, because X is geometric mean between this section and this section. I don't know either one of them, do I? But I could find one of them. I could find either this one or this one, because look, I got this, right? And I got the whole thing, so we'll call this A. Is that alright? And I'll call this B. Does that make sense? So watch, let's find this. If I can find this A right here, how can I find B very, very easily then? Just subtract it from 14.2. Well, look what I have. I have a geometric mean. Say they give me a geometric mean. This is the remember, the two legs are the geometric means, and this one in the middle right here is also a geometric mean. So this is a geometric mean between what and what? Between the whole thing and the segment that's adjacent to it, right? So look, I got the geometric mean, I've got the whole thing. I can solve for the segment that's adjacent to it now. So I can solve for A. Once I get A, take it away from 14.2, and I got B. And now I can go ahead and do the X. X is geometric mean between A and B, right? I've got them both. I'm good to go. Does that make any sense? Okay. It's kind of like a little puzzle at first. You got to figure out which direction you're going to go, right? Then actually going is not the hard part. It's actually figuring out which way I should go. All right, so this is the geometric mean. No, I didn't use it. Mr. Smith uses it. So watch. 7.6 is the geometric mean between what? Between the whole thing, 14.2, and what? The side that's adjacent, or the segment that's adjacent to that, which is A. Now look, I could cross multiply, but what am I going to do here? Just multiply by 7.6, right? Why can't I cross them out? Because I've got an equal sign in between. It's not a multiplication. Okay? No idea what that is. Let's stick some numbers in. 7.6 times 7.6, or 7.6 squared, right? And then what? Divided by 14.2. Divided by 14.2. And that gives you about, let's say 4.1, right, if I round it. So 4.1. So A is 4.1. What's B going to be? It's going to be 10.1, right? 14.2 minus 4.1 is 10.1. So I could do that without a calculator. And now I'm ready to solve for X. So now I can solve for this, because this is geometric mean between the two segments of the hypotenuse. We getting it? So X is the geometric mean between the two segments of this whole big hypotenuse. Now I know both of them, right? So now I can put these numbers in. 4.1 right here, 10.1 right here. Cross multiply, x squared equals, what is it? 4.1 times 10.1. Yeah, well, 41.41. 41.41. But then we got to take the square root. And
6.4.
do you? Good. So square root of my answer, 6.4. Is that the answer I read off? 6.4. Approximately. I put an equals there, but it should be a squiggle. It's approximately 6.4. There you go. All right, that's enough of that. We need to move on.
Crap.
Alright, can we pass them up?
Now look, these were at the end of the chapter, right? I did give you a second day to do this. Aren't you glad I didn't have you do these the first day? Yeah. So, I did give you, an idea how to do this. It was a little bit tougher, but that's okay, right? I don't mind giving you problems that are a little bit tougher. You should be glad that you're getting the tougher problems. You're an honors class, right?
Oh, we're just throwing them.
I'm sure you are.
I have no
Yeah.
idea.